Good morning, dear students. Today we are going to discuss part 16 of the chapter Laws of Motion. As in the previous video, we have discussed certain numericals based on kinetic friction, angle of repose, and we had also discussed about the kinetic friction and laws of kinetic friction. So, students, today we are going to discuss some theoretical part related to the kinetic friction, in which we will discuss about the types of kinetic friction, and in type of kinetic friction we will discuss about sliding friction. Then we will discuss about rolling friction, laws of rolling friction. After that we will discuss about friction is a necessary evil, why it is called as necessary evil, and then we will discuss about the changing friction, how we can change the friction by increasing, how we can increase or decrease the friction between the two bodies. And after that, one application we will discuss regarding the friction, that why it is easier to pull a long roller than to push it. So all these things we have to discuss today. So let us start about the sliding friction. Sliding friction. The sliding friction is nothing. Sliding friction is, it is a type of friction, or you can say that kinetic friction. Kinetic friction. It is a type of friction or kinetic friction in which it acts between one body with respect to other when they slides over each other. When they slides over each other. To explain this, I want to take an example. Suppose this is a rough surface. This is a rough horizontal surface. We had supposed this surface as A, and there is a car. Suppose there is a car. This is body B, and car is moving in this direction. So as the force F is applied over the car, then so as force F is being applied over the car, a force of friction F comes into play. That is called as the static friction. It is called as the static friction. But if we are going to increase the applied force F, then if we are going to increase the applied force F, then the static friction also goes on increasing, and it reaches to its limiting value. And after that, if we increase the force above the limiting value, then this friction becomes the kinetic friction. This friction becomes the kinetic friction. Now, the frictional force between the rough surface A and the car B. So, the frictional car is moving in this direction. The frictional force between frictional force on B with respect to A. Frictional force on B with respect to A, it is in this direction, and frictional force on A with respect to B, frictional force on the tires of the car with respect to B is in the right direction. It is in the right direction. If the car is moving in this direction, the frictional force will be in the right direction, and it will be in the left direction. Again, suppose second example I am taking. Suppose this is a rough surface. This is a rough surface, and a bus or a tanker is on this. A tanker is on this rough surface. Suppose this is surface A, this is surface B, and a car is kept on the top of the tanker. Then, if there is a relative motion between A and B, suppose the bus is moving with respect to A, then due to Newton's third law, a force in this direction which tries to oppose this impending motion between the B and C, and so a frictional force F is acting in this direction. So frictional force on C with respect to B, is along this direction, that is along right direction, and frictional force on B with respect to C is along left direction. So these are the two cases, and sliding friction is nothing. Sliding friction is the friction. Sliding friction is the friction when a body moves over the surface. It is just like moves or slides over the surface. Suppose this is the inclined plane, and a body is kept here, body A is kept here, and it is sliding in this direction. Then in this case the sliding friction acts, and it is the type of kinetic friction. It is one of the type of kinetic friction. So now we are going to discuss the next type of kinetic friction, that is rolling friction. So dear students, let us understand rolling friction. Now dear students, we are going to discuss second type of external friction, that is called as rolling. It is called as rolling friction. So student, it is a type of external friction. It is a type of external friction. It is a type of external friction in which one body rolls over the other body in contact. So this rolling friction, now I am making it clear that in case of static friction, the interlocking we had discussed about the case of interlocking. While discussing the friction, when we had started the chapter friction, we had discussed about the interlocking between the two surfaces. Interlocking, this is the interlocking. This is the interlock. This is the interlock. Means if in this way, suppose this is the surface and this is the object, then this is called as the interlocking. So in case of rolling friction, in case of static friction, interlocking is maximum in case of sliding oblique kinetic friction. Kinetic friction, interlocking is less, and in case of rolling friction, in case of rolling friction, only one point is always in contact at a time. At a time, only one point is always in contact with the surface. So in this case, interlocking is least. Interlocking is, in this case, interlocking is least. It means to say that suppose we are saying about a will, this is a will, and this will is in contact with the rough surface, then at a time only this point A is in contact with the rough surface. So here the interlocking is least, or interlocking is minimum. So since the interlocking is least, it means to say that the force of friction also decreases. It results that force of friction decreases. So, dear students, I want to say here that if we want to decrease the frictional force between the two bodies in contact, then we try to convert the sliding friction into rolling friction, and I am explaining it with an example, with a diagram. I am explaining it. So dear students, how can you understand the rolling friction as compared to the static friction and the kinetic friction or sliding friction? So suppose we had taken a box of mass m, we had taken. This is case A for static friction. For static, this is the case of static friction. And here it is the force, applied. Here it is the force applied. So as the force is applied in this direction, a frictional force acts in this direction. Now here interlocking is maximum. Interlocking is here. Interlocking is maximum, and since interlocking is maximum, so the maximum force is applied. This force applied will be maximum to move the object. And why the force? So as the force applied is maximum in this case, so the frictional force or F static is also maximum. Now the second case B is for the kinetic friction. For the kinetic friction means the body of mass or this box of mass m is not static, it is moving. It is moving with velocity v. And if the block of mass m is moving with velocity v, then applied force is less as compared with case A. As compared with case A. Applied force and interlocking. Why here interlocking is less than in case of static friction? Because when the object is moving, it has counterparted whatever the force or whatever the opposition offered by the interlocking. So here the interlocking is less than as case of static friction. So interlocking is less in this case. In case of kinetic friction, this is static friction, this is kinetic friction, and Fk has less value. Now we will see about the third case for the same block of mass m. If we had applied the wheels on this box. Now look at here. The normal reaction is same. Normal reaction is not going to be changed. But the interlocking between the wheels and the flow, is less. Interlocking is list. So F applied is list. F applied is list, and the rolling friction Fr has list value. Fr has least value. Fr has list value. Dear students, the normal reaction in all these cases, the value of friction is changing, but the normal reaction in this case, and in this case. So the normal reaction is same, and so as the normal reaction is same, but the interlocking between the two surfaces is changing, due to which it is easier to move. It is easier to move the object on the rough surface for the less interlocking between the object and the surface over which the object is moving. So we can say that Fr is less than Fk is less than Fs for the same mass placed over the surface. Now we will discuss about some laws of rolling friction. Dear students, now we will discuss about laws of rolling friction. So first law of rolling friction is similar to as in case of limiting friction or kinetic friction. It is directly proportional to the normal. It is directly proportional to the normal reaction, and it does not depend upon the area of cross section which is in contact with the surface. So we can say that rolling friction is directly proportional to the normal reaction. Second thing is, other than all the laws of friction, one thing is being included here, that it is inversely proportional to the radius of curvature in contact with the surface. It is inversely, so this is equation 1, it is inversely proportional to the radius of curvature of the surfaces in contact. Okay students, means Fr is inversely proportional to 1 by r if r is the radius of curvature for the surface. Suppose I am taking the rough surface in this way, and suppose an object is in this way. There are points, suppose this is point A, this is point B, and this is point C. Clear students? So the radius, what this curve is here, whatever the radius of the curve, the frictional force is inversely proportional to the radius of the curve. Okay students, I think you had understood it. This is equation number 2. Now combining 1 and 2, Fr is proportional to capital R upon small r, and Fr is equal to mu r. We have replaced the proportionality with a constant and changed this proportional as in equation. So Fr is equal to mu r capital R upon small r. Fr is equal to mu r capital, where r is the normal reaction and r is the radius. So as in the previous cases, we had discussed that the coefficients, that is coefficient of kinetic friction and coefficient of static friction are the ratios of forces, of forces. So they have no unit. They have no unit. But Fr or mu r has unit of length, as it depends on radius of curvature. So it has the unit of length. So dear students, this is the coefficient of rolling friction we had calculated and we had discussed about this. This is the condition this condition is called as condition of rolling without slipping. This is the condition. Fr is equal to mu r, capital R upon a small r is the condition for rolling without slipping. So this is about the laws of rolling friction. Now we are going to discuss about conversion of sliding friction into rolling friction, and friction is a necessary evil. Two things we are going to discuss right now. So these two things are theoretical. So let us understand it. So now dear students, now we are going to discuss about